Hello, so I'm going to go through some of the important functions we discussed in class. So to begin with, when you turn on your calculator, you're going to have the screen. So what I recommend that you do always is to just go to a new document, and you can just go to add graphs. Now, for example, just remember a few things we saw. If I type in, let's say, x to the power of 3, out, no, not here, to be down here, let's say minus x, and I press enter, I can see a graph. Now notice that the graphs will have a name. In this case, it's going to be called f1, and that's going to be important later on. Now this is a function, so it means that for different values of x, I calculate the value of f of x by putting the same value here. So if I put that x equals 1, I'm going to get f of 1 equals 1 to the power of 3 minus 1, which is 0, which is why there's a point here at 1, 0. I can calculate certain things now. If I go to menu, I can go to analyze graph, and we've looked at 0. How did 0 work? All I have to do is tell the calculator, hey, I want to find out when this function crosses the x-axis. Now, if you look at the bottom left, it's asking me for the lower bound. What the calculator needs me to do is to define an area in which to look for the place where the function crosses the x-axis. So if I click here, and then I click here, you can see that it's defining an area in which to look for the place where the function crosses the x-axis. And now it will give me the answer. It's at -1, 0. I can insert another function by going to menu, graph entry, function. And for example, now I can just write, let's say, 3 minus x. And there you go. That's another function. This one is called f2. Another thing we discussed is how I can go to menu, analyze graph, and intersect. When I click intersect, it's basically to find where two functions cross. So again, it needs me to represent a lower bound and an upper bound. The calculator needs help to know where is it that I'm looking for that intersection. So I click here, and it will give me the place where they intersect. Now notice, as we said, that 1.44 probably has more decimals than this, is actually going to be the solution to the equation x cubed minus x equals 3 minus x. And it was doing that we learned how to solve any equation using the calculator. One more thing that we talked about, which is very important, is how I can limit what I see on the screen of my calculator. Now, right now, I'm looking at a calculator from -10 to 10 on the x-axis, and from -6.67 to positive 6.67 on the y-axis. I can change that by going to menu and going to window settings. This is very important. So I can say, well, I'm only interested in seeing from -2 to 2. And on the y, I'm going to put the same thing, from -2 to 2. When I do this, I'll get to see in my screen from -2 to 2 and from -2 to 2. This is very important because a lot of the questions in the papers are going to ask you to draw a graph within a particular region of the graph. So by going to window, you can just have your calculator show you exactly what it is that you need to show. So that can be very handy. One last thing that we learn how to do with the calculator. Notice again that I have f1 of x here and I have f2 of x here. So one thing I can do is I can go to Control and add a page. And now I can add a calculator. This is a new document where I can do calculations. So here, if I write, for example, 2 plus 3, it will give me the answer. One nice thing I can do is I can say, hey, calculate f1 of 3. And it will automatically tell me f1 of 3 is 27. because that's x to the power of 3, so 3 to the power of 3, which is 27, minus x, which is 3, so 27 minus 3 is 24. If I calculate f2 of 3, I get 0. And again, if I calculate f1 of 1.44, I'm getting 1.54. If I calculate f2 of 1.44, I'm getting almost the same answer. Notice that, of course, there's going to be more decimals here, which is why in the graphs this is the point where they intersect. Although here I'm not getting exactly the same answer, it has to do with the decimals that have been lost. This is very important because it allows me to, again, calculate for larger numbers. Now, this is important, again, if I go to my graph, I'm going to now click here on the graph of, there you go. I don't want to show this graph anymore, neither do I want to show this one, but I do want to add a new graph. So go to menu, graph entry, and you're going to add a new function. It's going to be f3, as you can see. This is going to be 2 plus x divided by x plus 2 divided by, let's say, 2x minus 4. Now I can't see very well here, so one trick or something I can do so that I get to see what's going on here with more precision, go to menu window and click on zoom fit. This is just a good way to find your graph. Sometimes you plot something and you can't see anything. So if you go to zoom fit, you'll get to see a little bit more maybe. Well, that didn't help very much. Look at what happened with the Y. Look at where it went. 21,000, and I can't see anything on the screen. So zoom fit is not that perfect. What I can do that's probably better is go to Windows settings and go back to my -10 to 10, -10 to 10. And now I can see the graph very well. It can be quite tricky to find graphs, and the main thing is going to be our understanding of what they look like just by looking at the function, but also a little bit of practice in general, and just moving around with Windows settings, zoom fit, and other tools to be able to find your graph on the screen. Now here is my graph. We studied this type of graph. These are called rational functions. So we know that these ones have a vertical asymptote, which is the line the kind of curve is trying to become here, and a horizontal asymptote, which is the horizontal line that the curve is sort of trying to become as it goes away. The vertical asymptote is always going to happen when the denominator of the function is 0. Now in this case here, it's easy to see that that's going to be when x equals 2. And indeed, the line, the vertical asymptote is simply x equals 2. On the other hand, I have my horizontal asymptote. Now when is that going to happen? Well, if you think about it, you can see that it's becoming more and more the line as x becomes larger. You see, this is where x equals 10, and it's already sort of becoming that line. So a cool trick is to just go here and say, well, what happens when f3 is, let's say, 100? Oh, it's 51 over 98. What if it's 10,000? You can see what's going on here. 5,000 divided by almost 10,000? Even larger. 500,000 divided by almost a million? Well, clearly, this is becoming closer and closer to 0.5. So I can therefore assume that the function is coming closer to the line y equals 0.5 or y equals 1/2. And that's a good way to find my horizontal asymptote too, just using the calculator. It's important so that we understand and we make sense of why we can also say a divided by c, as we saw in our little shortcuts. But it's important to understand why and how that works. Thank you very much for watching. Goodbye.